Leveling the motor mount. Once we're done with soft foot, have firmed down, checked, the next check for us will be leveling the shaft. Now on a motor, what's key on why we bother with leveling the motor? Really two reasons. The most important reason is for the bearings of the motor itself. If they are horizontally mounted, it is the least amount of end loading on a bearing. If we had our motor tilted up, the weight of the bearings would tend to slide towards the back and rub against the back side. If the motor was tilted forward, the bearings would tend to slide towards the front and rub against the front side. When they're level, the support of the bearings is strictly the rollers themselves on the roller bearings and not the end mounts of the bearings. The rollers themselves are what's meant to be contacted by the rest of the motor, henceforth allowing freer motion. So for reduction of torque and also for bearing wear, we like to level the motor. Consider that since it's the bearings that we're concerned with on the rotor, or the turning part, what we then go to level is not the entire motor or the housing, we go to level the shaft, because that is the part that's connected directly to bearings and is in line with the bearings. So in our shaft, we go to level it. Now in leveling, we don't get the entire shaft because notice here is a portion silver, no paint, that's machined, and then we can see a little shoulder and an unmachined part of the shaft. We only want to put the level on the part that's machined. Not back here, but as I'm sliding this level, over against the shoulder. So what we're going to do is level our motor via a bubble level, looking at the shaft and align the bubble, and then use that information to shim the motor to raise or lower until we get a typical level. Now if you remember back on our level, we want our bubble to be in between the two black lines. When it's in between the two black lines, that's when it's level. Now there's one additional thing we have to watch out in math. When we do level this, notice we'll use again the same horizontal level that we had before, plus feeler gauge, sheathing under here. But when we level this, it's really only this distance that we're leveling across. Notice when we shim the bolts, most of the time these bolts are much wider apart than the shaft is. So there's what we call a shim ratio. In other words, we have a ratio of this length to this length, so we have a shim height versus a shim height. And typically we need more shim than what the feeler gauge will indicate. We'll go over the math of that a little later on, but for right now, we'll go ahead and take our measurements. Then we'll find with a feeler gauge what we needed to level the shaft with. And then using our shim ratio, we will multiply that times the shim ratio to calculate what we need to shim this with. Finally shim it, and then check our level again. Quite a bit to remember, but with practice, very easy to do. So once we have our motor all tightened up, next step is to use the level. And for this, I'm going to move the camera over so you can get more of a direct shot. Now we have our level, and we put it on top of the shaft as best as we can. In this case, it's a flat edge. We would prefer to have the little notch so it lines up more perfectly. But if we can't fit that notch in, then we wind up with a shorter level. We put this on top of the motor, and as you can see from the lighting, the bubble is a little bit towards the motor. In other words, it lines up against this back line, but is distance away from this black line. That means that this part is too high, so that we have to lift the front up to get this bubble up. And I'll lift it up by hand first. And about there is where we're level. So to more precisely lay it out, I'm going to use a feeler gauge and some of the sheaths in it. Now I'll start off with a guess, and I'm going to guess probably about 0.009. I'm going to guess that. So I put my level on top, and I will put my feeler gauge down, and I can see the bubble has moved over a little bit too far out. So 0.09 is a little too high, probably a 0.07. And notice that I have a 0.06 here. 0.06, so we'll try that since I have it handily. That's actually still a bit high. So I'll guess about a 0.05 or 0.04. 0.04. And yes, this is a bit of trial and error. And that looks like it's just about perfect. So it looks like I have about a 0.004. But here's the critical question. Is that what I use for the actual shim? Looking out at a distance again, remember, it took a 0.004 shim to level this distance. However, I want to level this larger distance. Notice when I tilt the ruler a short distance, roughly about 1.25 inches, 1.75 inches, I tilt up a little bit this way. There's a little bit of height here on this side. But if I go a long foot, you can see that same tilt, I have a lot higher distance to go than when I have a short distance to go. This is part of the shim ratio, and that the ratio of this shaft to these two bolt heads gives me the ratio of I must shim by. Now notice when shimming on the motor, we're not going left or right. That's already, as far as anybody cares, level enough. The leveling is strictly front to back, because the bearings, it's the front of the bearing, the back of the bearing that we worry about the loading. In a circle, it's a wheel. It really is, there is no such thing as leveling in this direction. So since we're going forwards or backwards, unlike soft foot where we only had one place to shim, when you shim for raising a front end or raising a back end, notice there's no lowering, can't go through the bed plate. Raising a front end requires shims on both ends in the front. Raising the back means both shims go in the back on either side. So if we put two shims at a time, the same shim depth. If we use the same thickness, we will not recreate a soft foot. If we use a different thickness, we will have a soft foot condition recreated. So going through the shim ratio, we have to figure out with our ruler what our distance is. We will measure this distance to this distance. And on this one, we measure 0, 1, 2, 3 inches, center of bolt to center of bolt. So it's a 3-inch distance here. This distance from the machine part to about the end is 1 3/4 inches right here. So our shim ratio is 3 to 1.75. 3 divided by 1.75 times 0.004 is 0.00685. So we round off to the nearest whole mil, or 0.007 thousandths of an inch. So what we're looking for is a shim of 0.007, possibly 0.006. And we look for the combination that gives us that. Now to get to a shim of 0.007, we really don't have, we have a 5 plus 3 that would work, but more likely what we do is we look for a differential. Now what I can come up with, and we have to do mathematically, we're left with 0.0003, 0.005, 0.0010, and 0.020. This gives us a hint. 0.020 versus 0.010 plus 0.003. So a 10,000th and a 3,000th together is 13,000th. 20 minus 13 is 7. So what we want to do is raise our front by 7. What we can do is raise the front by 20 and raise the back by 13, and we've effectively raised the front by 7. So we do that for, in the front side, 020, and I find another 020 and put it under this front side. On the back side, the combination of 010 and 003, and on the other back side, behind the camera, 010 and 003. So just like we had with the case of the softfoot, now we're going to loosen the bolts and slide all 4 sets of shims underneath the feet and then recheck. We'll recheck for our levelness. So it's a matter of loosening, and we do that basically all around the horn. And again, get in the habit and torquing. There's a little side note here. Get in the habit of doing things diagonally. So I loosen all 4 bolt mounts diagonally. What this does is keep from warping mounts, plates, and particularly if it's aluminum or a softer metal that we're dealing with, and not very thick, then we want the ability to be able to move around. So I loosen up all around the horn. There we go. It's all loose. And now I'll proceed to take these shims and insert them underneath the risers if possible. Here we already have a collection of shims. Remember that from the softfoot. And so we attempt to go ahead and place these underneath that. I have finished pushing the shims underneath all 4 feet. Notice I have kept all the shims from softfoot effort as well, so that all the shims go underneath, preferably between the bed plate and the riser. Last thing left for us to do is to recheck our level. And lo and behold, I'm going to move the camera. We've checked out softfoot. We've leveled the motor. Last things to worry about doing is end float and run out.